Okay, so folks, I've been asked to have a go at a couple of questions to help you out. So the first one that I was asked about was exercise 9B, question 10. Now I'm doing these straight away, so hopefully I can do it quickly and easily without making too much of a mess of it. I haven't started it yet. So question 10 in 9B says that a dart is thrown at random onto the board shown, and the board looks like this. The board is a square of side length x, so the side length here is x. The largest circle is of a radius of x on 2, so that's x over 2. And the smaller radius is x over 4. X over 4. Now my family's just come home, so if you start to hear people chatting in the background, you'll know what's going on there. Hopefully they're not too noisy and we'll get through this easily. Okay, part A says find in terms of x the area of the square. So if I want the area of the square, that is simply x times x, which equals x squared. If I want the area of the larger circle, so the area of the large circle, so I'll put L circle, is going to be pi, brain's not working, it's the end of the day, pi r squared. So in this case it's pi times x over 2 squared, which is the same as pi times x squared all divided by 4, because I've got to square both the top in this expression here. I square the top and the bottom line. And then part 3 is I want the area of the small circle. Now same deal, it's pi r squared. In this case it's pi times x on 4 squared. And same deal as before, I square the x, I square the 4, and I get these 3 expressions for the areas. Alright, part B. Part B says find the probability that the dart will land inside the smaller circle. Okay, so inside the smaller circle, so the probability of in the small circle is going to basically be, okay, well, how will I be successful? I'll be successful if I land inside the area of the small circle, which is equal to pi x squared on 16, divided by the total possible area, which is x squared. So on the top line here, this is my success, and this is the total possible. Alright, so this is relatively straightforward from here. I've just got to have some good algebra skills to work through it. So I've got a fraction divided by a fraction. So there's my top line divided by x squared on 1. Now I've written it as a fraction divided by a fraction because then I can use the idea of flip the second one upside down and multiply instead. And by doing that, I can see I've got an x squared on the top and an x squared on the bottom. They cancel each other out, and I'm left with a final answer of pi divided by 16. Now if I type this into the calculator, I will get a decimal approximation. Just trying to find my calculator here. A decimal approximation of 0.19635. 0.19635. Now if I think about that logically, that's about 0.2. 0.2 is roughly 1/5 of the shape, and if I look at the diagram in the book, 1/5 makes sense. So that's logical. But please don't turn it into a decimal for any other reason than to help your understanding. Please leave it as a fraction. All right, part 2. Now part 2, I'm just going to start over on the right hand side here. B part 2 says find the probability that I'm in the white region. Now the white region is this space here. Now if you haven't already looked at the diagram, you probably really need to open up your textbook and have a look at the diagram right now if this is going to make any sense. Okay, so the white region, so the probability of the white bit, how can I be successful? Well, the white bit, the area of the large circle, I've actually left out a part above, so my answer above might be wrong, but the area of the large circle is, we had pi times x squared divided by 4. Now that's the whole white circle, and that's assuming that the red part hasn't been taken away. But that's what we need to do in this problem, is we need to actually take away the red part, because I don't want to land in the red part, I want to land in just the white bit. So the chances of me being successful to go into the white part is the area of the large circle take away the area of the small circle. And then the total probability is x squared. All right, so now on my top line, I need to put those two bits together, and I'm going to get a common denominator. And the way I'm going to get a common denominator is timesing both the top and the bottom line by 4 here. And then that will give me 4 pi x squared on 16, take away pi x squared on 16, all divided by x squared, and then that becomes 3 pi x squared on 16 divided by x squared. And if we use the idea of the flip and multiply from the previous problem, but just do it the short way, that x squared and that x squared will cancel out, and I'm left with a final answer of 3 pi on 16. So that is the probability of landing in the white area. And then the final part of this question, I'm assuming, is what's the chances of landing in the outer shaded area. So the outer shaded area will be the green space. Now my diagram up here has been messed up. We're talking about landing in these outside corners here. And again, if you haven't looked at the diagram in the book, please have a look at the diagram in the book. We use the same process for this one. The whole square is x squared, and then we need to take away the area of the larger circle, which was pi x squared on 4. Okay, that's what we had up the top here earlier. Pi x squared on 4. So then that's the ways I can be successful. Divided by x squared. I can do some shortcutting here. I'm just going to write it as x squared over x squared take away pi x squared on 4 divided by x squared. And then that allows me to quickly do some cancelling out. That will cancel out with that. That will cancel out with that and leave me with 1. So then I get 1 minus pi on 4. And then that could be my final answer, or I could get a common denominator here, or just use common sense. 1 take away pi on 4 will be 3 pi on 4. Oh, I don't know if that's right now that I've said that. Let me actually just check. Let's go back a step. I'm doubting myself. Maybe it's because it's the end of the day. 1 is pi on pi. And then I need to get a common denominator. So to get a common denominator, that is not useful at all. Definitely the end of the day. Let's write that 1 is 4 on 4. So then I want 4 minus pi all divided by 4. So that's my expression with a common denominator. And if I type that into a calculator, I get, just doing that on my calculator now, 4 minus pi, all divided by 4, and a decimal approximation is 0.2146. So again, if I look at the diagrams, that roughly 1/5. Yes, it's roughly 1/5. My answer seems on track. And that's the end of 9B question 10. A reasonably tricky one that had a fair bit of algebra and a bit of area knowledge in there as well.